This is a demo of Anycast server selection using SR tunnels and the tunnel selection based on data collected from in-band OAM. What we will see in this demo is an Anycast service offered by multiple servers. The initial connection request from the client towards an Anycast service is replicated to multiple servers using SR tunnels. Response to the connection, that is SYNAC, is evaluated based on the in-band OEM data collected, and a server selection for the Anycast service is done. Based on the selected server, SR tunnel is set up and all the subsequent communication will take that tunnel. This is the viral setup for the Anycast demo. Anycast service is an Nginx web server. An instance of it is connected to each VPP 1, 2 and 3. The client accessing the service is connected to VPP 0. In-band OEM is enabled on all these nodes to collect node ID, TTL and timestamps as the packet traverses through them. In-band OEM is enabled for SYN and SYNAX, and the data collected is evaluated at VPP 0 for Anycast service selection. For the purpose of the demo, there is asymmetric routing setup as follows. The packets from client connected to VPP 0 towards server at either VPP 1, 2 or 3 follow one path, while the return traffic, that is from server towards client, take the other path. What you see here in the viral demo setup is link from client towards server 1 is forced to add an additional 100 millisecond delay, while the path from server 2 and 3 towards the client add an additional 20 millisecond delay. So what this means is the round trip time from client to server 1 is higher than server 2 and 3, but the path from server 2 and 3 is slower than from server 1 towards the client. This is the VPP 0 console in the demo setup. This is the node that is connected to the client. Here we have set up tunnel selection based on one-way delay. That is, it picks the server with least delay from server to the client traffic. So I'm going to execute, this is the client, and I'm going to execute HTTP content access from this client towards the Anycast address. Since one-way delay is selected, one-way delay for server selection is selected, and we have server 1 with least one-way delay from server to the client, server 1 should always be picked, and that's what is happening. Now let's go back to VPP 0 and change the selection criteria to round trip time and try accessing the same content from the client. Now either server 2 or 3 should be selected because the round trip time between client and server 2 and 3 is less than that of server 1. Back to VPP 0 console, this is what happened. Towards the Anycast address, there are 3 possible servers and hence 3 different SR tunnels. Based on the server selection, one of the tunnels is active and other 2 become inactive. Here, since the last access to the Anycast service from the client picked server 3 based on the round trip delay, tunnel towards server 3 is active, while SR tunnel towards server 1 and 2 are inactive. Let's look at the trace. So what happened is the initial SYN packet towards the Anycast service was replicated and sent towards each of the three servers with in-band OAM data inserted. The response from each of the servers received had the in-band OAM data populated for the entire path, which could be used to calculate server selection criteria, which could be round trip time or one-way delay in this demo. And based on the server selection, the packets from two of the servers is dropped, while the selected server is picked and the SR tunnel towards that server is kept active.